Hi, my name is Nagaraju, and here is the title History of Motor Protection. The motor protection is necessary in order to get the performance and the lifespan of the motor high. And here is the introduction to motor protection. Motor protection refers to the set of techniques and devices used to safeguard motors from damage or failure. So every motor has the protection devices, that is in order to protect the motor from damages or failures. So there are the techniques and the devices. The history of motor protection dates back to the early 20th century with the development of basic overload protection devices. Over time, advancements in technology have led to more sophisticated motor protection methods to ensure efficient and safe operation. So, motors are mainly used in so many industries: automation, traction, and in domestic commercial purpose. So, in order to get the efficient output and safe operation of the motor, the protection devices or the protection techniques are must be followed, and these devices must be connected in incoming or the motor, so that there will be a reliable operation or reliability in the motor operation. So the different devices are used for different motors based on the type of motor, based on the supply, or based on the rating, with the different techniques. And there is early forms of motor protection. In 1900s, simple overload relays were commonly used to protect motors from overheating due to excessive current. So, when the motor takes excessive current, the winding gets damaged due to overheat. So, in early, that is in 1900s, in those time, simple overload relays are commonly used to protect these motors. So, a thermal overload relays were introduced to monitor motor temperature and trip the circuit if it exceeds a safe threshold. The threshold is nothing but it is a safe limit value. When it exceeds, it is a current or it is a voltage. When it exceeds the threshold value, automatically the winding temperature will rise, so that this relay which are used, that is thermal overload relays, were used to monitor the temperature, and it trips the circuit, so that the motor is safe. And after there's a fuses and circuit breakers were also utilized to protect motors from short circuits and overcurrent situations. If a short circuit occurs in the motor or in the winding of the rotor or the stator, the overcurrent will result. That is, the motor takes the overcurrents. On that time, these fuses and the circuit breakers will protect the motor. Evolution of motor protection devices. The introduction of electronic overload relays in the mid 20th century allowed for more precise monitoring and protection of motors. Solid state motor protection relays became popular in the 1980s, offering improved accuracy and flexibility in motor protection. Today, microprocessor based motor protection So today microprocessor based motor protection relays provide advanced features such as remote monitoring, diagnostic, and predictive maintenance. The technology is improving so that microprocessor based monitor protection relays are used. It compares or it provides more remote monitoring and diagnostic and predictive maintenance. Importance of motor protection. What is the importance? Why we need to protect these motors? Motor protection is essential for preventing costly downtime, equipment damage, and safety hazards in industrial and commercial applications. As we know, if the motors are used in industry and commercial, so in order to avoid the equipment damage or to avoid loss, so that the motor protection is necessary. And proper motor protection helps extend the lifespan of the motor, reduce energy consumption, and improves overall system reliability. Compliance with industry standards and regulations regarding motor protection is crucial for ensuring workplace safety and equipment reliability. Types of motor protection. As you know, there are different types of motor protection. There are common types of motor protection devices include: one is overload relays, another one is thermal protectors, then circuit breakers and fuses. Overload relays are used, and these relays will operate when there is a overload, that is a connected load to the motor is high than the motor bearing capacity. And the thermal protectors, which are used in the winding when it exceeds the threshold limit, these will operate. And the circuit breakers and fuses, which operate when there is a short circuit. And here is the thermal protectors, which are used in the winding. Motor starters with built-in protection features such as motor monitoring, phase imbalance detection, and ground fault protection are widely used. Advanced motor protection systems may incorporate motor conditioning, monitoring, vibration analysis, and predictive maintenance tools for early fault detection. Challenges in motor protection. The following are the challenges. That is, selecting the appropriate motor protection devices and settings can be challenging due to varying motor types, sizes, and operating conditions. Interfacing motor protection relays with control systems and communication network requires careful integration and programming. Maintenance and testing of motor protection devices are crucial to ensure they function properly and provide effective protection against faults. And here is the image about the control system which is integrated to the relay, right? Which is programmed. The following are the future trends in motor protection. Those are the integration of smart sensors, IoT technology, that is Internet of Things, and artificial intelligence is expected to revolutionize motor protection. Predictive maintenance strategies utilizing data analytics and machine learning algorithms will enable proactive identification of motor faults. Energy efficient motor protection solutions and renewable energy integration will drive innovation in motor control and protection systems. And here is the case study in motor protection. One is implementation of a motor protection relay system reduced downtime and maintenance costs in a manufacturing plant. Case study 2 is integration of condition monitoring sensors improved the reliability and efficiency of a motor driven pump system. And the third case study is upgrading motor protection devices in a commercial building enhanced electrical safety and compliance with regulations. And the following are the best practices in motor protection. Those are regular inspection and testing of motor protection devices to ensure they are functioning correctly and within specified parameters. Conducting motor load analysis and thermal modeling to optimize the motor protection settings for efficient operation. Training personnel on proper installation, maintenance, and troubleshooting of motor protection systems to minimize risks and maximize performance. And here is the conclusion of this topic is the history of motor protection has evolved from basic overload relays to sophisticated microprocessor based systems reflecting advancements in technology and industry standards. The motor protection plays a crucial role in ensuring the safe and reliable operation of motors in various applications, from industrial machinery to commercial buildings. By staying abreast of emerging trends, implementing best practices, and leveraging cutting edge technologies, organizations can enhance motor production strategies and drive operational excellence. Thank you.